In this video, we're going to talk about the second type of factoring, which is called grouping. Alright, so let's look at this example. Ax plus ay plus bx plus by. Again, remember factoring is reversing multiplication. So let's we need to figure out what, so the answer should look like this. What times what equals ax plus ay plus bx plus by. Okay, because so far we have learned only one type, GCF. And if we try to do GCF, we are going to see that it doesn't work. Because GCF, that is something that goes into all of the terms. When we look at all of these, we cannot find anything, any number or letter that goes into all of them. And well, you may say 1 goes into all of them, but if you factor out a 1, nothing's going to change. You're still going to get the same thing, ax plus, because you divide everything by 1, you're going to get exactly the same thing. That's not called a factoring. Just like when I ask you to break down 6, you cannot just do 6 times 1. We usually like to exclude this case. It is factoring, but we like to usually factor them into prime numbers, and the numbers are different from 6 or 1. So the same thing here. If you factor it as 1 times itself, it doesn't do us anything. Okay, so let's see what we should do to break down this expression. So the idea is, well, first of all, let's see. So again, 1 goes into all of them, but we're not going to factor out 1 because it's not going to change anything. The letter A goes into the first two. Notice that these two, they both have A's, but the other two don't have A's. The other two both have B's, but unfortunately, the first two don't have B's. And you may see the first and third, they both have X's, but the other two don't. And the third and the second and the last, they both have Y's, but the other two don't. So we can see we cannot find a number or a letter that can go into all of them, which means we cannot find a GCF except 1. Again, we're not going to use 1, factor out of 1. So let's see. We can see GCF doesn't work because there is no GCF. Maybe I can just put no GCF here. So it doesn't, there's no GCF. It only means type 1 doesn't work. This is not type 1, but maybe it's not a type. And this is the exactly what we call grouping. So the idea is, because when we are checking for GCF, we noticed that the first group, actually X and AY, these two actually have something in common. And last two have something in common, the GCF. So we can do 2 groups. So let me just call this group 1, and this is my group 2. So usually we're just going to do 2 groups. We could have difficult ones with 3 groups or more, but we're only going to do 2 groups here. So let's see. Group 1, I noticed they have a GCF. So following the steps of GCF, so we found what they have in common, A and A, and you factor out A, and then divide both of them by A. As you can see, if you divide the first one by A, use a different color here, do division, so A cancels A, we're going to get X plus A cancels A, Y. So that's our first group. Now, second group, we're going to do, we found out they have a GCF, that is B. So we're going to factor out a B from both of them. And we divide both of them by B. And now we're going to cross out B, we got an X, cross out B, we got a Y. Okay, and then, but this is not the answer. Notice the final answer should look like something times something. What we have so far is something plus something. So we need to continue to do one more step to get something times something. Notice these 2 groups, after I factor them out, group 1, group 2, I found they still have something else in common, which is x plus y. See, there's x plus y here. There's x plus y there. So we're going to factor out x plus y. And if we divide both of them by x plus y, we're going to get cancel these. We're going to have a plus b. And notice the final answer is something times something. So to summarize the steps that we noticed, that we first break them into 2 groups, or maybe more depending on the problem we have. As we usually, you can divide the first 2 into put the first 2 in a group and the last 2 in a group. If you can find something common for the first 2 and something common for the last 2. There are other ways sometimes you can take the first and third and put them in a group, and second and fourth. But if you just follow the order, the first 2, if you can find something in common, last 2 can find something in common, you can just follow the order. And okay, so that's the first step. Divide the given whatever expression into 2 groups. You got to make sure that each group has something in common, which is called GCF. So as we did here, we have for group 1 we have A in common. For group 2 we have B in common. So that's the first step. The second step is you're gonna, for each group, factor each group to factor out the GCF. Factor the GCF out of each group. And when you do that, let's follow the GCF type. So I factor out A, the GCF A. And so this right here, A is our GCF for the first group, and B is our GCF for the second group. And you divide each one by A in the first group, divide each one by B in the second group. So after we get here, we're not finished. We have to do one more step. We need to factor out another GCF. Factor out another GCF. So technically, grouping is doing GCF 3 times. Usually we have 2 groups, so we factor the GCF out. There are two GCFs we got to do, and then you factor out another GCF. So we factor GCF three times. And over here we have GCF. It's like 2 terms, x plus y. And we factored the whole thing out. Okay, so now let's look at one more example. We can example 2. This time, in the first example, I have all pluses. This time we're going to put some minus signs in there. So example 2. We have 5x cubed minus 5. We can maybe do 10. Actually, 10x squared. And minus 3x and plus 6. Okay, notice again 5, 10, 3, 6. We can't find anything in common, so that's nothing except 1 that can go into all 4 numbers. 5, 10, 3, 6. And then the letter, we notice the last one doesn't even have x. So that means they don't have any GCF. Again, so this one has no GCF. When you look at all 4 of them, they don't have any GCF. Because x, the last one, 6, last term does not have x. If the last term has x, then they have x in common. But the last one doesn't have x. Okay, so let's look. Let's see how we do GCF. How we do grouping. Following the steps. So first, we're going to break them into 2 groups. So these 2 will be in one group, and these 2 will be in one group. Notice this minus sign goes with the number there. Okay, so we have two groups now. For the first group, we factor out the GCF. So we follow the GCF type. 5 and 10, we found the GCF that is 5. And x cubed and x squared, we take the lower exponent, so which is x squared. So that's the GCF for the first group. And then we're going to divide each one by our GCF, 5x squared, 5x squared. And now we do 5 divided by 5 is 1. X cubed divided by x squared is x. 3 minus 2 because it's 1. Minus 10 divided by 5, that's a 2. X squared divided by x squared, they're cancelled. So we got x minus 2 here. And next we're going to factor the second group. When we look at the second group, we notice 3 and 6, they both have a 3 in common. 3 goes into both of them. And they don't have x in common. So we're going to factor out a 3. If we factor out a 3, there is a little problem here. Let's see what happens if we factor out a 3. So let's divide both of them by 3 by 3. So that's our GCF. And notice negative 3 divided by 3. Be careful, this minus sign goes with that 3. We do negative 3 divided by 3, that gives us negative 1. And then x would be negative 1 times x here. And plus 6 divided by 3, it's 2. Well, in our next step, so because I factor out a negative, factor out a 3, which is a positive 3, so we should put a plus sign here. But the problem is we cannot do the third step. We need to factor out another GCF. But when we look at them, different from the previous case, in example 1, we found out there's another GCF x plus y. See, x plus y, x plus y. But in this case, we got x minus 2 and negative 1 times x, which is pretty much negative x. Negative x plus 2. They look very close, but they're different. This is positive x, but that one is negative x. And this is negative 2, but that one is positive 2. They're different. See if we can compare the x minus 2 and negative x plus 2. They're different. The difference is they're opposite. Positive 1, we have negative 1. Negative 2, we got a positive 2. They're opposite. So if they're different, you won't be able to continue to do the third step to factor out another GCF. So what should we do? Well, we notice that, okay, if I get this minus sign out, I can get a positive x to match that. And then get a minus out of here, I can get another minus to match that. So let's see how that works. So I'm going to erase all of this and redo this process. So the first group is fine, no problem there. We just have to work on redo the second group. So in order to get a positive x to match what we already have in the first group, we can factor out a negative 3. Instead of factoring out a 3, we can factor out a negative 3. So let me put a minus sign here. So not positive 3 like we did it before. We're going to factor out a negative 3. And now let's divide again. So negative 3 divided by negative 3, that gives us a positive 1. And then there's x. 1 times x, that would be just x. And then notice here, it's a positive 6 divided by negative 3. That will give us a negative 2. Because positive divided by negative is negative. And now let's look at again. They match now. See, x minus 2 and x minus 2. They are exactly the same. So we are able to continue the third step to factor out another GCF. So there's another GCF from here, which is x minus 2. So let's factor out this x minus 2 from here. Get rid of that. And again, we do division. So when you divide it, pretty much you just cross out whatever you have. So if you put divide by x minus 2 here, and this will be cancelled. If you put divide by x minus 2, the whole thing will be gone. And we're going to be left with just 5x squared minus 3. Okay, so that's the final answer. So this 5x squared right here, down here, and minus 3 down there.